Hi, this video is on finding the greatest common factor and factoring. So what we're going to do is talk about how to find it and then how to factor, of course. There are some algebraic expressions where the greatest common factor is what we use to factor them. Let's take a look at these examples. So we have 3x minus 18. This expression has two terms. One is 3x, the other one is 18. And what we're looking for is something that both terms can be divided by. Basically what's going to go, the maximum, the largest quantity that can go into both terms. The numbers 3 and 18 can be both divided by 3, right? And that's the largest number that can go into both. Now what about the variable? Well, you have a variable x here, you don't have any variables here, which means there's no way for you to factor out the variable. And essentially when you factor something out, you are dividing by that. So that means what we're going to do, we're going to take 3x and divide it by 3, and we're going to take 18 and divide it by 3. So factor out, so we're going to take 3 outside of the parentheses, and then we're essentially dividing each term by that. So we divide 3x by 3, that's going to give us x. We divide 18 by 3, that's going to give us 6. This is the factored form. I want to show you one thing that will tell you how to verify your work. So what you need to do is, if you take this expression and you distribute everything back, you're supposed to have your original expression. So if I do that, what am I going to have? I'm going to have 3 times x, which is 3x, minus 3 times 6, which is 18. This is precisely what we had. So this is the correct form of our expression. Okay, let's take a look at the next problem. So we have 9y plus 6. Obviously there is only one term that contains the variable, so variable is out of the question. Between 9 and 6, what is the greatest quantity I can factor out between 9 and 6? That is number 3. Okay, so the greatest common factor, I never wrote that. The greatest common factor here is 3. The greatest common factor here is also going to be 3 because it's the greatest quantity that goes into both 9y and 6. So what we do is we put 3 outside, and then we factor it out, so we divide each term by that quantity. So 9y divided by 3 gives you 3y, 6 divided by 3 gives you 2. You can verify that again by distributing. If you distribute 3, you will get the same exact polynomial. Okay, let's take a look at the next. So we have 49z and 7. Between 49 and 7, the greatest common factor between them two is going to be 7. Can I factor out the variable? No, because this term does not contain a variable. So 7 is the greatest number that's going to go into both 49z and 7. So I'm going to put that outside and I'm going to factor. So that's what I do when I factor out. Then I'm going to divide each term by 7. So 49z divided by 7 will give you 7z. 7 divided by 7 will give you 1. You need to be very careful here. It's actually a very common mistake. Sometimes students think that 7 divided by 7 cancel and nothing's going to be left. This is absolutely incorrect. The 7 divided by 7 does not cancel. 7 divided by 7 gives you 1. So when you divide 7 by 7, you are going to end up with 1. The number of terms that you're going to have inside of the parentheses, once you factor something out, has to be the same number of terms that the original expression had. So I have 2 terms here. That means my parentheses will have 2 terms as well. And again, you can check it by distributing. So this will be our answer. Let's take a look at some more examples. Okay, now we're getting into some more complicated expressions. Some of them have, well, they have 3 terms and some of them have multiple variables. So let's see how it's going to work with those. Let's take a look at the first one, 9x plus 6xy minus 3xz. I usually recommend students take a look at the numbers first. between 9, 6, and 3, what is the greatest factor? The greatest common factor. The greatest common factor for 9, 6, and 3 will be 3. Is that all? Well, let's see. What else do we have common besides the number 3? Well, we have x here, we have xy here, we have xz here. Every term contains one x, so we can definitely take x out. Is there anything else we can take out? No, because there's the only variable here. This variable, this term has y, but nowhere else you have y. This one has z, and nowhere else you have z. So that means we're going to factor out 3x. What are we going to be left with? Well, you're going to, just like the previous examples, you're going to divide each term by that quantity. So 9x divided by 3x will give you 3. 6xy divided by 3x, let me write it here on the side. If you're dividing 6xy by 3x, you are going to simplify these two. That's going to leave you with 2 over 1. Simplify these two, that's going to leave you with 1. And the whole thing will simplify to 2y. So plus 2y minus 3xz divided by 3x will leave you with z. That is the answer here. Moving on. Let's take a look at the next example. So we have 18a minus 6ab minus 30b. Again, just like I mentioned earlier, let's take a look at the numbers first. So 4 numbers, 18, 6, and 30. What's the largest number that goes into all 3? That will be 6. What else do we have that is common? Remember, they call it the greatest common factor because they're common things. We have a here, but we don't have any a here. We have b here and b here, but no b here. So there is nothing else that can be taken out. So 6 is going to be all. So we take 6 out and we divide each term by 6. 18a divided by 6 will leave you with 3a. 6ab divided by 6 will give you 1ab or simply ab. And 30b divided by 6 will give you 5b. That's a. Okay? And that is the answer. Again, all these can be verified by distributing. I want to show you really quick here as just as an example again. If you distribute 6 times 3a will give you 18a, 6 times ab will give you minus 6ab, 6 times negative 5b will give you minus 30b. You are supposed to get exactly the same expression. Alright, next problem. Let's take a look. So 15, 5, and 7. 15, 5, and 7 do not have any common factor besides 1, so we're not interested in that. Is there anything else we can take out? Well, let's see. We have q, q, and another q. So each term has q. We can definitely take q out. What else do we have? We have r and p, but they're like randomly scattered, so we can't really do much there. That means our greatest common factor is just q, and we take it out. 15q divided by q will leave you with 15. 5qr divided by q. Q is going to be gone, leaves you with 5r. And then plus 7qp, q is gone, leaves you with 7p. Alright, and that's this. Alright, now we're going to take a look at situations when you have higher exponents. So, 15q cubed minus 5r. Well, just because we have exponent does not necessarily mean anything. You know, exponents that are higher. Again, we're going to start it the same way. We're going to take a look at numbers first. So 15 and 5, obviously both divisible by 5. That's the greatest number. But your variables are different. So 5 is the only thing we can take out. 15q cubed divided by 5 is going to leave you with 3q cubed. 5r divided by 5 will leave you with 1r or simply r. That is the answer. Now let's take a look at a more interesting situation. So you have 15x squared y plus 14y. Let's see, let's start with numbers again. 7 and 14, what's the greatest number that goes into both? That is 7. What else? You have x squared here, but there's absolutely no x here, so we can take x out. You have y here and y here, so we can definitely take one of the y out. So that's gonna leave us with 7y, and we divide each term by 7y. So 7x squared y divided by 7y, 7's cancel, y cancel. You're gonna be left with x squared. 14y divided by 7y will leave you with 2. Alright. Next one. So we're looking at the numbers first. The number in front of this is 1, the number here is 5. There is no common factor between those except 1, so we don't care about 1. Now let's take a look. You have m cubed here, but there is no m here. This one has n squared, this one has only one n. So n squared does not go into n, but n, the single n, goes into n squared. So we can factor out one n, just one. We cannot factor out n squared because you don't have that many here. So we're going to take n out. So we got m cubed n squared divided by n. That's going to take one n out. That's still going to leave you with m cubed. And it's going to be n minus n. 5n divided by n will leave you with 5. Okay, and remember, all these can be verified by distributing. Alright, moving on. I have a few more examples. They look scary, but don't be afraid. They are not that bad. So let's take a look at this one first. 5, 30, and 6. These three numbers do not have a common factor besides 1. And please be careful, because it may look like 5 times 6 is 30, which it is, but that does not mean anything, because we're looking for a number that's going to be divisible by all, the number that's going to go into 5, 30, and 6, and there is no such number except 1. But what about the variables? We have x cubed here, no x here at all, x squared here, but that's irrelevant, there is no x here, so x is not going to be used. Y squared, y cubed, y squared. What's the lowest exponent? Y squared. You have y, at least y squared in each term, so we can factor out y squared. What are we going to be left with? 5x cubed, y squared, divided by y squared. Y squared and y squared are going to become 1. You're going to be left with 5x cubed. 30y cubed divided by y squared. First of all, 30 will remain. Y cubed divided by y squared, that's going to cancel 2 of the y's, but you're still going to have another one left. So 30y minus 6x squared y squared divided by y squared. I think you can see it's going to leave you with 6x squared. Okay. Next problem, let's see what we have here that's common. Our greatest common factor, let's start with numbers again. Greatest common factor, 14, 49, and 7. There is the greatest number that's going to divide all three will be 7. Because 14 is divisible by 7, 49 is divisible by 7, and 7 obviously is equal to 7. What else do we have here? You have p squared here, p cubed here, but just one p here. You're going to have to go with the lowest exponent. That's just going to be p. Q squared, q cubed, q squared. So we can take out q squared. That would be the lowest exponent, which means we can take it out. Alright, so what is going to happen now? So you take 7pq squared. 14 divided by 7 is 2. P squared divided by p is 1p. q squared divided by q squared is 1, so nothing. 49 divided by 7 is 7. P cubed divided by p is going to leave you with p squared. Q cubed divided by q squared is going to leave you with q minus 7pq squared divided by 7pq squared is not nothing, it's 1. Remember, the number of terms in parentheses when you take out the greatest common factor must match the number of terms in the original expression. So 7pq squared divided by 7pq squared will leave you with 1. Okay. And our last example in this lesson, 120d cubed f h squared plus 45d f squared h minus 9dh. So let's see, greatest common factor. We have 120, 45 and 9. It's a little bit, one of the numbers is kind of big. So let's see, 3 goes into all three numbers, 120 and 45 and 9. Can we go higher? Well, the only other option you have is 9. And 9 does go into 45, but 9 does not go into 120. So we're gonna have to go with 3 only. How about the letters? Now let's see, we have d cubed, 1d here and 1d here. So we're gonna have to go with the lowest exponent, so it's just 1d. F squared, but no f here, so f cannot be used. H squared, h cubed, h. You have h in every term, but the lowest exponent is 1, so just h. That is our greatest common factor. So 3dh is factored out. 120 divided by 3 is going to leave you with 40. D cubed divided by d is going to leave you with d squared. F is going to stay. H squared divided by h is h, plus 45 divided by 3 is 15. D divided by d is 1. F squared is going to stay here. And h cubed divided by h is going to leave you with h squared. And then finally minus 9 divided by 3 is 3. D and h, that's going to give you 1. So that's all that's going to be left here. And again, I want to remind you, every single one of these problems can be verified by factoring, which means if you have any doubts about your work or you just want to check it, you can always distribute the quantity outside over all the terms and see if you're getting your original polynomial. Okay, and I hope this helps.